So, good morning. It's a real pleasure to be here to give you a brief overview of what we have obtained with the mass spec metabolomics data on this sub-cohort. And I will briefly present for some people who are not really familiar with those overall integrative approaches, omic approaches, going from gene to metabolites. Metabolomics, which is the last born omics approach, is assessing the metabolites of the tissue or a biological fluid, and those metabolites are the closest information, the closest entity to the phenotype. So it allows to have a comprehensive response to biological systems. So it has been defined as the characterization of a biological system via the simultaneous measurement of metabolites present in the system and accessible for analysis. But in fact, there is different ways to do metabolomics. You have the targeted approach where you analyze a number of metabolites very accurately, or you can have a broader approach where you analyze way more metabolites, of course, less accurately, but in that untargeted approach, you get a global fingerprinting of the subject or the biofluid that you assess, and it's the best way when you want to discover new biomarker and able to discriminate with these biomarkers, control from case. So that's what we have done in this study. So we have used high-resolution mass spectrometry to analyze biofluids, blood, serum, and urine sample, and get global over fingerprinting, measuring or assessing thousands of metabolites to identify biomarkers. In this study, we had two main objectives. First, to discriminate PRE-FRAIL from non-frail subject at T0, and then to analyze the effect of the Mediterranean diet in those two groups. So first, we analyze people from Italy and Poland at time 0, and we observed, as Claudio mentioned this morning, that we have people who remain stable over this intervention during 1 year, and we have people who change their status. And we have two different ways of changing the status, going from pre-frail to non-frail. They improve their frailty status, or we have people who went worse. So, in order to better understand the effect of the diet, then we decided to analyze people who didn't go through the diet but changed their status over time. So, before going further, I just want to present you some of the characteristics of this subject that we have analyzed. So, at baseline again, at time 0, related to the frailty status. We have analyzed people who are not frail, non-frail, and frail status, a frail subject, male and female subject, from Italy and Poland, and you see those two groups were not perfectly balanced. In terms of possible confounding factors, we have and population distribution, again related to the frailty status. The age can be a problem. It was not perfectly balanced, but the gender and the country were the distribution was perfectly balanced. Okay, and here you can see that in the non-frail, pre-frail male and female subject, there was no significant differences in terms of age, BMI, or SPPB score. So then we analyzed the serum sample by metabolomics, and in terms of effect, again, at T0, there was a country and gender discrimination, so bigger for country. And when we analyzed the whole data set, analyzing the sample at time 0 and time 1, the country was the most important factor. Therefore, when I will present you all the sample later on in this presentation, I will present you data from male and female subjects, with country always taken into as a cofactor, and we will compare them. So first of all, I will present you discrimination of the pre-frail and non-frail subject at time 0, and we have observed that untargeted metabolomics reveals subtle changes between non-frail and pre-frail subjects, because we obtain markers of pre-frailty in male and female subject, in subjects that remain the same status, non-frail or pre-frail in male and female. We have markers of the status that in this subject that are improving their status, that mean pre-frail, non-frail, or we have markers of people who are becoming worse, here, exemplified here, so they are coming from non-frail to pre-frail over time. There was absolutely no common markers between male and female subject, and only few markers common between those three status. And you have to keep in mind that those data are obtained at T0, so that means that those markers are able to predict the evolution of those subjects over time. So we have evidence of gender and pre-frailty status differences. So those results were suggesting that, in fact, in the pre-frailty status, we have, in fact, different subphenotype and people who are able to evaluate differently over time. So as the metabolomics data were able to differentiate potentially 3 different phenotypes, we were trying to analyze the characteristics of those patient of the subject with these 3 different subphenotypes. And here you can see that taking into consideration age, BMI, or SPB score, there was no significant differences. However, we are continuing to analyze the data, and we're starting to analyze body mass composition. I cannot present you the data today, but there's some starting to have some significant differences in terms of BMI composition or even nutrient intake. So we are continuing to go further. Then we analyze the effect of the diet. So that means comparing the data time 0, time 1. So we started to analyze the rough estimation of the compliance data. And as you can see, for pre-frail subject or non-frail subject, stable or changing the status, there are no significant difference in terms of compliance. They all improve the compliance by a factor which is around 10. So no significant difference in compliance. The effect of the diet, basically those people who were all taking the diet the same way, whatever the evolution of their status. Then we analyze the data we have on the nutrients that have been obtained from the food diary, and we have observed that there were 7 nutrients that were significant. They were consuming less saturated fatty acid and improving the consumption of some other nutrients. Then we were trying to identify biomarkers of the diet, and we were convinced that by analyzing the people who are not changing that status were the best way, because the frailty status didn't change, though if there were some changes that could be related to the diet. So we have analyzed those subjects, and as you can see, we have biomarkers that are significantly different in male and female, and there are some common metabolites. If it's related to the diet, it's quite, I should say, it does make sense. And we have 2 markers that are exemplified here. When we look at the 50 metabolites and correlate that with the nutrients, we have 43 metabolites that are significantly correlated with 11 nutrients that we have analyzed, and they are correlated positively or negatively with the nutrients. Again, we have analyzed the same thing in the urine to identify potential biomarkers of the diet in the urine. We have, again, some biomarkers, no common metabolites between men and females. And when we analyze the correlation between those metabolites with nutrients, we have correlation in females with some nutrients and in males with other nutrients. Again, no overlap between male and females. Now we have analyzed the changes, the people who improve or went worse. So again, we have some markers None of them are common between male and females. When we have one biomarker of improvement in female, diet specific, that means that this biomarker was only seen in those people who went through the intervention study, and which is also a marker of pre-frailty. We have one biomarker of worsening, diet not specific, that means that we also see that in those people who are not going through the nutritional intervention, but who are going to be pre-frail at the end of the study. And is also a marker of pre-frailty at T0. We have one biomarker of pre-frailty status change. That means that it is improving when the people are improving their status, and it is decreasing when they are becoming worse. We have found few markers of the diet, and 8 of those metabolites are correlated with the nutrients. So basically, we have shown that untargeted metabolomics enable to discriminate subphenotype of pre-frailty with gender differences and pre-frailty status, that these untargeted metabolomics allows identifying food markers of dietary intake, and it enables to phenotype frailty status changes. So it really, this untargeted approach opens a door towards a better patient stratification. Before finishing, I would like to thank those people who have been working hard on the platform first, from data analysis to all those statistics, and in my group. Thank you for your attention.